Welcome back, everyone, to our continued discussion of tree-based methods when it comes to machine learning models. In this section of the course, we're going to focus on an extremely popular machine learning algorithm based on tree-based methods known as the random forest. Random forests have the ability to greatly increase the performance based on expanding ideas from the decision tree model. And in general, random forests are known as ensemble learners, since they rely on an ensemble of models. Technically speaking, that just means that we're not actually just working with a single estimator or a single machine learning model, we're actually dealing with many machine learning models. And in the particular case of random forests, we're going to be working with multiple decision trees. In this section, what we're going to do is first cover the motivation and history behind the random forest. And if in previous sections you've been skipping over the history, you definitely want to watch this history lecture in this particular section because a big part of it is the motivation and the construction of how we go from a decision tree to a full random forest. Then we're going to discuss the wide variety of hyperparameters that we can begin to adjust on a random forest that were not available to us in a single decision tree. Then we're going to work through an example of using random forest for classification, and then an example of using random forest for regression. And in this particular lecture on random forest regression, we're actually going to compare many regression models against each other. We'll go back and check out support vector regression as well as decision tree regression, and just compare the various performances and various metrics we can apply with these variety of machine learning models on the same continuous labeled data set. Okay, we got a lot to cover, so let's get started. I'll see you in the next lecture.